Hi, this time I am going to discuss SWOT analysis of Internet Protocol Security. First, let me discuss what is Internet Protocol Security or IPSec and its uses. IPSec or Internet Protocol Security is a suite of protocols that secure network communication across IP networks. It provides security services for IP network traffic such as encrypting sensitive data, authentication, protection against replay, and data confidentiality. What are the uses of IPSec? First, to encrypt application layer data. Second, to provide security for routers sending routing data across the public internet. Third, to provide authentication without encryption, like to authenticate that the data originates from a known sender. To protect network data by setting up circuits using IPsec tunneling in which all data is being sent between the two endpoints is encrypted, as with a virtual private network or VPN connection. Now, let us define what is SWOT or strength, weaknesses, opportunities, threats of Internet Protocol Security. Strength of IPsec. First, network layer security. 2. Confidentiality. 3. Zero dependability on applications. Network layer security. IPsec operates at layer 3, the network layer. As a result, it has no impact on a higher network layer. In other words, one of the biggest advantage of IPsec is its transparency to applications. The end user need not have to bother about the IPsec or its configuration. 2. Confidentiality. Similarly, the second strength of IPsec is that it offers confidentiality. During any data exchange, IPsec uses public keys that helps to safely transfer confidential data. As a result, securing the keys ensures safe data transfer. 3. Zero dependability on application. IPsec only requires modification to the operating system. As a result, IPsec-based VPNs do not need to worry about the type of application too. That's not the case with SSL-based VPNs, where it requires modification to individual applications. This is yet another reason for the popularity of IPsec. Weaknesses of Internet Protocol Security. First, wide access range. Second, compatibility issue. Third, CPU overhead. Wide access range is one of the greatest weaknesses of Internet Protocol Security. Giving access to a single device in IPsec-based network can give access privilege for other devices too. For instance, imagine that you are connecting to a corporate network from your IPsec-based home network. Here, if any of the computer in your home network has malware in it, it can easily spread to the computers in the corporate network. Unless there are special security mechanism, vulnerabilities that exist at the IP layer will pass on to the corporate network across the IPsec tunnel. Compatibility issues. IPsec brings in couple of compatibility issues with software too. This happens when software developers do not adhere to the standards of IPsec. Similarly, when you are already on IPsec-based VPN, connecting to another network will be rather impossible due to restrictions in firewalls. Again, IPsec does not provide support for multi-protocol and IP multicast traffic. CPU overhead. Unfortunately, IPsec is well known for the high CPU usage. It requires quite a bit of processing power to encrypt and decrypt all the data that passes through the server. When the data packet size is small, the performance of the network diminishes due to large overhead used by IPsec. Stay away from IPsec-based VPNs in scenarios where there is only small-size data transfer. Opportunities of Internet Protocol Security. First, reduce key negotiation overhead and simplified maintenance by supporting the IKE protocol. IKE provides automatic key negotiation and automatic IPSec security association setup and maintenance. Second, good compatibility. You can apply IPSec to all IP-based application systems and services without modifying them. Third, encryption on a per-packet racket than per-flow basis. Per-packet encryption allows for flexibility and greatly enhances IP security. Threats of Internet Protocol security. First, man-in-the-middle attack. Second, password cracking. Third, buffer overflow. Man-in-the-middle attack. As we already saw, IPSec VPN uses keys to identify each other. In this vulnerability, an attacker may be able to recover a weak pressured key. Thus, this attack targets IKE's handshake implementation used for IPSec-based VPN connections. Using these keys, it can decrypt connections. Ultimately, it will open the door to man-in-the-middle attacks. Eventually, this will result in leakage of VPN session data. Another problem with IPSec happens with password cracking. Unfortunately, this happens with both IKE v1 and IKE v2 versions. When a VPN user enters a password, server first encrypts it and compare with stored values. If they match, the person gets access. Unfortunately, using weak passwords with IPSec VPN makes it vulnerable to offline dictionary or brute force attacks. That's why it is recommended to choose extremely complex passwords when they use IPSec through password-based logins. Additionally, we make sure that VPN uses cryptographically secure key values that can resist brute force or dictionary attack. Lastly, another IPSec vulnerability is buffer overflow vulnerability. Buffer is nothing but a temporary storage space. At times, a program may forget buffer location and overwrites adjacent memory locations. This vulnerability happens due to a buffer overflow in the affected code area. Here, attacker would first send UDP packets to the affected system. As a result, it allows attacker to execute arbitrary code and obtain full control of the system. That would be all for SWOT analysis of Internet Protocol security.